Hello, this is AP Chemistry Review 3.8 Representation of Solutions. In this video, we'll be talking about different ways that you can represent solutions, both when ionic compounds are dissolved in solution and also when molecular compounds are dissolved in solutions. This is an important topic on the AP test, as they often want to make sure that you understand what's actually going on to the particles inside of a solution when you have a solvent and solute interacting with one another. So a lot of times we'll represent a beaker like this. And a solution, remember, there's two parts to a solution. There's the solvent, and that's the part of the solution that's doing the dissolving. It's usually water, and it's present in the larger amount. And then there's the solute, and that's the substance that's being dissolved in the solution, usually present in the smaller amount. Most of the time, you won't see a visual of the solvent. It'll just be assumed that there's a solvent in the beaker. And then you'll see particles inside of the beaker. These particles can be like water, and most of the time water will be represented something like this, where you have the two hydrogen atoms bonded to an oxygen atom. Or you'll have ions, and the ions can be represented a few different ways. They could just be represented with positives or negatives to represent their charge and not their identity. Or they actually could identify the identity by putting the symbol inside the circle with the charge. Remember, each circle represents an atom or an ion whenever you have a diagram like this. So just make sure that you count things, because you do have to have balanced charge inside a solution. So if you have two positives, you also have to have two negatives to balance that out. That's an important part of solutions when ionic compounds dissolve in solutions. So one of the questions that you need to be really aware of is, how do ionic compounds dissolve in water? What does the water do to the ionic substances? And so remember, ionic solids are alternating charged, positive, negative, depending on what the ratios of the charges are. If it's two positive and one negative, then you would have half as many two positive ions as you do negative ions. But let's assume that you have a 1-to-1 ratio. So how does this solid, and we represent solids by putting the particles very close together, saying that they're attracted to each other. How does an ionic solid dissolve in water? Remember, water is polar. Water has a partial negative and a partial positive side. The hydrogen side is the partial positive side of the molecule, and the oxygen side is the partial negative. So the partial positive is going to be attracted to the negative ions in a ionic crystal. And so that water molecule will come over, and the positive side will pull off the negative ions. And so you'll end up with a negative ion being surrounded by water molecules' positive sides. And again, the word for this is hydrolysis. These water molecules are hydrolyzing that negative ion. And so the positive side of water molecules will attract to the negative side of the negative ions in an ionic crystal. And then the positive ions in ionic crystals will be attracted to the negative side of water molecules. And again, they surround it to hydrolyze it. So that is a particle representation of what's going on with ions when they dissolve in water. The water molecules actually rip the ions apart, and now those ions are free to move. And this is a particle representation of that. If we want to show that the ions are free to move in the solution, we're going to draw them separate like this. If we want to represent them as a solid, then we would put them together, usually towards the bottom. Something like this, to show that they're actually a solid and they didn't dissolve in the solution. Another way they could represent a solid is just by a little diagram like this, and say this is a solid or a precipitate. The other thing to think about when you're talking about ions in solution, or any particles in solution, is how many are there relative to another solution. So if we had two solutions, and one had ions drawn like this, and one had ions drawn like this, remember, in a solution with ions in it, the charges have to balance out. Which one of these solutions would you say is more concentrated? Remember, concentration is the amount of solute per amount of solvent or per amount of solution. So if you look at these two drawings, we can see that this one is more dilute and has a lower concentration, and this one's more concentrated. There's more ions per solution. And so dilute solution, concentrated solution. So in particle representations, we can talk about the state of matter by how close the particles are to each other. We can talk about how the particles interact with one another. And then we can talk about concentration by looking at the relative number of particles in solutions. Another thing to think about when you're thinking about solutions is not just how ions dissolve in water, but how do molecular compounds dissolve in water? Remember, like dissolves like. And what that means is that polar molecules dissolve polar molecules, and nonpolar molecules are more likely to dissolve nonpolar molecules. So like dissolves like, and apparently I can't spell. So like dissolves like. So polar substances dissolve polar substances. So how does that work? Well, let's say that you had an ammonia molecule. So ammonia is NH3. And so here's an NH3 particle representation, or one way to represent it. And let's say you had a water molecule. So we have a water molecule. So remember, these two particles are both polar. There's a lone pair on this nitrogen that makes this polar. Water is polar. And not only that, but we have an NH bond and we have OH bonds. And remember, substances that have NH, FH, or OH can attract each other through hydrogen bonding. So how does that happen? Well, the negative side of one molecule will attract the positive side of another molecule. So the positive side of the NH molecule is the hydrogen side, and the negative side of the water molecule is the oxygen side. And so we represent these intermolecular forces, these attractions between these molecules, with dotted lines. And that means that these two molecules are attracted to each other with a hydrogen bond. Why is it a hydrogen bond? Because hydrogen bonds exist between molecules that have OHs bonded to each other, NHs bonded to each other, or FHs bonded to each other. If it's any other polar molecule, it would just be a dipole-dipole interaction. So let's say that you had, let's draw a generic polar molecule. And let's just say this molecule is polar and it has a positive side and a negative side. And so if we had a water molecule, let's draw our water molecule like we drew it earlier, like this. How is this water molecule going to attract this polar molecule? Well, polar means that one side is negative and one side is positive. And usually that means partial negative and partial positive, which we represent with these little deltas. So the positive side of the water molecule is going to be attracted to the negative side of the polar molecule. And so again, we draw this little dotted line to represent an attraction between the negative side of one molecule and the positive side of another molecule. So that is a way that we can represent a polar molecule dissolving in a water molecule. So these are various particle representations of solutions. Again, we talked about quite a few different things to look at here. There are lots of examples of particle representations of solutions that you could work through. You want to look for practice problems in 3.8, and you'll see a lot of examples of how particle diagrams need to be interpreted. But this is just a basic rundown of different ways that you can represent solutions with particle diagrams. If you have any questions, let me know, and I'll be happy to help you out. Good luck.